Objective number 3. Use the quotient rule for exponents. Definition. For any non-zero real number a and any integers m and n, a to the nth power divided by a to the nth power equals a to the m minus n power. Basically what this is saying is, if you're dividing two powers that have the same base, you can get the result by keeping the base and subtracting the exponents. Example 1. Simplify. Assume that all variables represent non-zero real numbers. Part A. 6 to the 12th power divided by 6 to the 9th power. Well, as you can see, we're dividing two powers that indeed have the same base 6. So we can keep the base 6 and subtract the exponents. Therefore, we get 6 to the 12 minus 9 power, which is 6 to the 3rd power. Evaluating 6 to the 3rd power by taking 6 times 6 times 6, we get an answer of 216. B. 4 to the 6th power divided by 4 to the 11th power. Once again, we're dividing two powers that have the same base, so we can use the quotient rule by essentially keeping the base and subtracting the exponents. And when we do so, we get 4 to the 6th minus 11 power, which is 4 to the minus 5 power, which is 1 over 4 to the positive 5 power. And so the answer becomes 1 over whatever 4 to the 5th power is, which is 1 over 1024. C. 7 to the 5th power times x to the 10th power divided by 7 to the 6th power times x to the 11th power. In this scenario, we can rewrite this problem as 1 over 7 to the 6 minus 5 power times x to the 11 minus 10 power, which gives us 1 over 7x. Now the reason we can do that is, again, since the denominator contained the higher exponents in each case, we can bring each of the numerators to the denominator and do the subtraction. But when you do that, you have to replace the numerator by 1. And once you do that, you're able to do the subtraction from there and get 1 over 7x. Part D. 3 to the minus 1 power times the quantity a plus b to the minus 3 power, where a does not equal minus b, divided by 4 to the minus 2 power times the quantity a plus b to the minus 4 power. Okay. In this particular scenario, we can take the a plus b to the minus 4 power in the denominator to the numerator position, and when we do that, we can change that negative exponent to a positive exponent, and so we end up with a plus b to the minus 3 plus 4 power. And that will end up with us obtaining a plus b to the first power, or a plus b. Then we will interchange the position of 3 to the minus 1 power with 4 to the minus 2 power. So 3 to the minus 1 power in the numerator goes to the denominator, becoming 3 to the positive 1 power, which is 3. 4 to the minus 2 power, which is in the denominator, gets taken to the numerator position and becomes 4 to the positive 2 power. Therefore, we get 16 over 3 times the quantity a plus b. Or you can write it as 16 times a plus b over 3. Both answers are correct. This one is. Oh, we still got some, don't we? Or do we? Yep.